Welcome, everyone. Sorry about the small technical difficulty there in the beginning. But yeah, welcome. This is our fifth Adaptive Cloud Community Call this year. And if this is your first time joining, hello. If this is your fifth or fourth or third time joining, my name's Kiana, and Thomas and myself here will be the moderators for this call today. This call is focused on the Azure Adaptive Cloud Community product and service updates. So topics presented range from Azure Arc to IoT to AKS to Azure Stack HCI. Oh, let me flip slides here. And then, yeah, presenters today will go over their topics and we'll engage in a Q&A session at the end where we open up the floor for all of you to ask any questions that you may have. If you have any questions for the presenters, feel free. Or if you have questions just for general topics that weren't covered during the presentation today, feel free to also raise your hand. It's an open forum for anyone to discuss any questions they have. Feel free to also take advantage of the Q&A button at the top. It should be at the top of your Teams, and we can also have offline chats there. Let me flip to the next slide here. Now there's a couple more folks still joining. So this is our GitHub. This is a public repository, so all of you should be able to go and access this now if you want. Our GitHub acts as kind of this one-stop shop where you can get all meeting links and recordings, all of the resources that we have, all of the calendar invites, and that type of stuff. So that leads me to the YouTube page. So if you're interested in looking at our previous recordings, you can visit this aka.ms link here. All of these meetings are recorded, and this is a non-NDA call. So anything that is discussed today, it can be publicly discussed anywhere. So like I said, this is a recorded call. So if you happen to miss a previous call, or if you want to check out some of our previous recordings, that's all available on our YouTube there. So one new thing I wanted to discuss today is our Azure Adaptive Cloud Community LinkedIn group. So you can join using the ak.ms link there to request to join. It's a public group, so if you want to share any posts within the LinkedIn group, once we make a post, or if you make a post, then other followers or other connections that you have within LinkedIn can also see that post. We wanted to do it this way just because obviously we have the Teams channel, which is great. But if we're trying to gain more traction, or if people have, major updates that they want to announce publicly to MVPs, to their connections, to whomever, then this is a great way to do that. So feel free to join that LinkedIn group, and we can go ahead and get started then with the agenda. So yeah, today we have a pretty packed agenda, and I'm excited for all of the presenters to provide their updates. So without further ado, Francisco can go ahead and take it away.
Hey all, can you hear me?
Yep, can hear you.
Thank you, Kiana. Okay, so hi all, my name is Francisco Cabrera. I'm a senior technical program manager at the Azure Jumpstart team, and I'm happy as always to share all the Jumpstart news and represent, the huge work that the Jumpstart team is doing. Can you go to the next slide? Cool, thank you. So let's start a bit with the release highlights. So this, the July update was mainly kind of a maintenance release, so it was a lot of bug fixing, and I'll go a bit over that. But then we had a big Jumpstart assets, right? Kind of the APD, the Arc Architecture Poster and Diagrams release. So that one included new Azure Stack HCI diagrams. I think there was like 4 new ones and 8 updated ones. We have a new one regarding the SQL Server, enable SQL Server. We have, I think it's something like 4 new ones when it comes to Azure Arc Monitor pipelines. And we do have 2 new diagrams when it comes to multi-cloud connector. If we go a bit more into the details of the code, so the first thing across Jumpstart, we did update all our AKS Essentials kind of solutions to make sure the user can choose a specific schema version. So basically that helps us if you want to use a specific version of AKSE and you want to use a specific schema version, then now you can do it, there's no problem. And mainly also that's going to help a lot with the issues when the AKSE team was releasing a specific version. It should be compatible right now if you're using the correct schema version. Then when it comes to ArcBox, This is also an important change because right now the partial get AC access token is changing. There's going to be a breaking change, so we're updating the code to make sure that that's being used as a secure string. Then we have some updates regarding HCI box. A lot of small bug fixes, mainly around kind of the life cycle of the VM, mainly around the deployment, right? So if you can see, for example, right, there's a bug there around, like the parameter cannot be found. But again, gaining a lot of traction when it comes to HCI box and the new version of HCI box with the support of 23H2. And then finally, we need a updated, right, or our Arc-enabled data services solutions and scenarios, right, to make sure we're using the latest and greatest version of the Arc-enabled data services kind of bits, right, the latest container there. And then we do have some updates regarding drops. So Ken, if you can go to the next page. So, and this, we're getting a lot of traction when it comes to drops. We're getting more and more drops. We expect to have something like 4, 5 more this next month. But in July, we had these 4 new drops. So first of all, I don't know if you're familiar with LoRaWAN, but LoRaWAN is a technology that is gaining a lot of traction in the manufacturing space. So it's a way to communicate data through, in these small devices, with long range. So we have a great solution there in order to connect LoRaWAN devices all the way up to the cloud with Azure IT operations. Then we have another drop by Mike, one of our co-maintainers, in how to actually deploy the Azure Monitor agent to any Azure Arc-enabled server in a really quick way, so you can get that up and running with just a couple of kind of line of codes. Then we have one from Thomas, and Thomas will actually be talking about his own drop, but definitely recommending a great way to actually have this lab kit, the unofficial Azure Adaptive Cloud lab kit, and how to use that in order to run different Jumpstart solutions. And then we also have someone from the community a drop around, which is a dashboard, right, on how to view all the kind of Windows security, extended security updates through a dashboard on all the kind of Arc-enabled servers. So again, just wanted to share these drops. We have right now more like almost 40 drops, a lot more coming. So just go ahead, go to drops, check it out, and if you have any feedback, if you want to contribute, just feel free to reach out, and we're happy to help you there. So yeah, that's it from the Jumpstart site. Thank you.
Thanks, Francisco. Sumit, I believe you're up. Feel free to also request control, or if you want to present yourself, you can take over if you would like.
Yeah, sorry about that. I was having a technical issue. Okay, so I'm just going to take control.
Sounds good.
Can you see my screen move? Or
no, I cannot.
1 sec. So I went in and I selected the. Can you tell me the option again? Like I'm trying to.
Yeah, you should be able to. I'm not sure where the button, I guess, is to request control, but for, I guess, the purpose of this meeting, if you just want to tell me to click through the slide,
Yeah, that's fine. Yeah,
I can do that as also. Okay, cool.
Yeah, that'll be great. Thank you so much.
Awesome.
So yeah, thank you everyone for joining. So today's topic is sensitive workloads and data handling. And specifically, this is a pretty broad topic. And in the context of this topic, sensitive workload and data handling, we are going to be talking about confidential virtual machines on the ASD platform. And the even though the topic is specific to confidential virtual machines, we're going to touch upon our plans in general for the edge for creating confidentiality across the different layers of the stack. So if we could go to the next slide, please. Kiana, if you could go to the next slide.
Oh, I'm in the data in use is encrypted in CVM. Should I go to the previous slide with the diagram?
Yeah, please.
You might
I'm
have to
sorry.
sync, might
Yeah, I
have to
did.
click sync to presenter.
Yeah, sorry, there's some technical glitch happening here. Yeah, so thank you. So I just wanted to quickly level set the context before we deep dive. See, we have been talking about the adaptive cloud landscape. We have this, we talked about Arc enabling the ability to extend on-premises to the Azure control plane. And then we talked about Kubernetes. This is kind of our general strategy for adaptive cloud. And I'm not getting into the detail here today. The intent of this is to talk about in context of the different parts and pieces of the adaptive cloud. Our focus today is going to be the Azure Stack HCI deployment. And specifically within the Azure Stack HCI, I'll be talking about enabling confidential VMs. So if we could go to the next slide, please. So what is the benefit of confidential VMs and what does it do? So quickly to summarize, confidential VM essentially extends the ability to encrypt data in use. See, today we have existing capabilities as part of the OS platform to encrypt data when it is at rest on the disk. We encrypt data while it is in motion over the network. Confidential VM specifically is a technology that allows us to encrypt data while it is running in the VM RAM. Now, why it is important is because most of these critical workloads, they have sensitive information, and we want to protect this information from the administrators of the infrastructure on which the virtual machine is deployed. Now, just to give a quick update on this, summary on this. So, like I said, VM content is encrypted, and it's encrypted by the key that is not available to the hypervisor. So, the hypervisor is not able to get access to that data. Now, in order to do this, the workload doesn't need to be rewritten or modified. Just because it's deployed in a confidential VM, the workload is going to achieve this. We don't need any further changes to the application itself. And finally, because of the promise of making sure that the memory, the data in memory is not available to the host, any of the operations, VM operations that force the data on the disk is not permitted. If you could go to the next slide, please. So since we talked about encrypting data in use, I wanted to quickly touch upon the fact that there are different ways in which hackers can get access to the memory, VM memory. We're not going to get into every detail, but think of it at a high level that there are tools that let us acquire the memory, the dump of the memory, the physical memory, and then there are tools that allow us to do analysis of that memory. So I've kind of given a few examples here, like you could use the WinPMEM to get the dump of the physical memory. There is the ability to attach a process to the Hyper-V using WinDebugger, and then you can inspect the memory and you can save a state. And like I mentioned in the earlier slide, we don't allow doing these operations, saving the state, because we want to ensure that the memory the contents of the memory is not available to the hypervisor. Now, just if you could go to the next slide, please. So as an example, if I may just belabor the point, I've used an example of a credit card because a credit card is relatable, and we want to protect credit cards from being stolen. But the idea there is this can extend to any data that we want to protect. Healthcare data could be other financial information. And especially in environments where there are multiple parties that are sharing data, it is important to make sure the other counterparties are not able to get access without authorization. So this example just belabors the point that in a regular VM, like you can see, uh, the admin of the host has access to the memory and they can get information. Uh, and if you're running in a CVM, you're protected. So primarily, if there is any vulnerability in the operating system, you'll be protected from that. If there is any kind of insider threat, we are going to be protected by running the workload in a CVM. If we could go to the next slide, please. So just to give a quick double click on how this works. Uh, so so what happens is that there is this component in the virtual machine, which we on the guest, which we call as the host compatibility layer. This is the layer that is generating a key, and that key is essentially not visible to the hypervisor. And more importantly, this contract that this key that is being generated by this layer, which we are calling as the host compatibility layer, it can be attested by the hardware itself. The fact that the hypervisor and the host will not get access to this key. And so that's the first. And then as part of this, we also ensure that the VM is booting up in a state that is secure. And that is the second part, which is where we take the boot measurements and then we attest that as well. So that's kind of at a high level how CVMs work. And of course, this VTPM is not going to be persisted, which is what we're trying to do here with the first drop of stateless CVMs. And next slide, please. Yeah, so I talked about how it works at a high level. We get this hardware attestation and we send it to Microsoft Cloud for attestation purposes. And that report can then be used to show up in a portal. You can use that to also generate alerts if you're deploying an infrastructure on, if you're deploying a workload on infrastructure that's not compliant. You could then use that report to make sure that, you could use that report to get alerts. And as part of that, you can ensure that the workload is always deployed in infrastructure that is compliant to such sensitive workloads. Now, the lastly, workloads can also decide that, okay, I have the infrastructure doing this, but I would like to attest independently. And they could actually have a process in place where any secret that the workload is loading in memory is only allowed after the workload has itself been able to attest that the workload is running in a confidential environment. So those are the options that are available for the workload. Finally, of course, like I mentioned, that we're starting the journey with confidential VMs, and the goal is to build confidentiality across all the layers of the stack. And we are planning a private preview sometime next year. So if there's interest on this topic, please reach out. And I've put my email there, so happy to take any questions if there are at this point. I don't know, Clara, if you're taking questions right now or we move forward.
We typically take questions at the end, but I guess if anyone had questions, I think we have time. Feel free. Or you can drop them in the Q&A if you think of them later.
Yep. Thank you.
Yep. If no questions, then we can move on to the next presenter.
Thanks, Kiana. Let me just take the control. Okay. Hello, everyone. Today we are going to talk about Azure Monitor Pipeline. So even before I jump into discussing what is Azure Monitor Pipeline, I'd like to spend some time to share our goals and the vision. So from the monitoring perspective, we have heard customers saying that they need consistent experiences for monitoring their resources, assets, devices in the exact same way that we have in cloud. So our overarching goal is we want to enable Azure Monitor, be it at your regardless of where your resources reside. They can reside in Azure Cloud or in other clouds such as AWS or Google Cloud or on-premise. We want to provide you that consistent monitoring experiences across your hybrid and multi-cloud environment. So with this in mind, we have announced public preview of our new capability, that is Azure Monitor Pipeline. So as you all know, or if you have used Azure Monitor for your cloud resources, you know how that overall solution works. Essentially, you have your resources which are listed here on the left, like they could be servers with agents installed, such as Azure Monitor agent. They could be a Kubernetes cluster with other capabilities enabled like container insights or managed Prometheus, or they could be applications emitting some data. So all that telemetry that is being emitted from your resources, they are sent to the cloud pipeline. And this is as of today. So when you emit, they are sent to cloud pipeline. Here you can perform some transformation using data collection rules, etc., and then send to respective stores for metrics and logs. And then you can build analytics on top of it using our visualization tool. Now this works perfectly fine if your resources are in Azure, or if your resources have direct line of sight to cloud, which means you can deploy Arc agents and connect them to Azure and then set them up for monitoring. However, in certain scenarios, it is very difficult for customers to follow the same path, meaning it's in some scenarios they cannot deploy Arc agents simply because it will void that manufacturer warranty, or the resources are located in some constrained environments where they do not have direct line of sight to cloud. So, and I'll discuss some of those scenarios in the subsequent slides. But in those scenarios, what we are doing is we are extending the pipeline capabilities at edge, meaning now you have this edge pipeline that you can configure in your on-prem environment to get the telemetry from all these resources that are situated in the constrained environments and then send it to cloud. So the cloud pipeline here, it doesn't require any setup. It is simply available to everyone out of the box to receive the data, transform, and send. However, this edge pipeline does require some setup. We'll talk about that. And then you can cater the collection as per your requirements. So this is essentially what we have announced in public preview back in April. All right, so why edge pipeline and what is this thing? So it's essentially a tool designed to facilitate really high scale data ingestion to route that telemetry from your edge environments to cloud. It's using Open Telemetry Collector as its foundation. So that brings a lot of richness and flexibility of open source tools, prevents vendor lock-in, and makes it really, really easy to get the telemetry from your on-prem environment to cloud. So when we talk to customers, they are like, our agents are limited in terms of the scale. So we have customers who are currently ingesting 6 million events per second for 1 KB message size. So that's the kind of scale we are looking at. And especially in manufacturing environments, there are so many resources, various types of IT, OT devices that emit really, really high volume of telemetry. So to achieve this kind of scale, this particular component will help them scale out horizontally and then help them route all the telemetry to the cloud. Again, coming back to the manufacturing world, there are customers who typically deploy their resources or have this ISA 95 Purdue network model. So once you have this segmented network model, your resources lie in particular segments, and they are restricted by the firewall since it's isolated. And if it's isolated, it's really difficult to deploy the components, Azure components, in those resources that reside in the segmented networks. So with Azure Monitor Pipeline at Edge, and there is another component in Azure that's called IoT Layered Network Management. So this is essentially kind of a proxy. So along with this, you can use this Edge pipeline to deploy it and get telemetry from the resources that are located in these constrained environments. Last but not the least, data loss is something that we all want to prevent. So in scenarios where, the customers face intermittent connectivity, either due to planned maintenance and security reasons or simply due to network outage, obviously they don't want to lose telemetry that's been collected during that particular duration. So what the edge pipeline helps you with is you can cache the data during that duration of intermittent connectivity and then backfill that once the connectivity is back up so that you don't lose the data, you have continuity in your observability. Currently, like I said, Azure Monitor Pipeline at Edge is in public preview. We support syslogs and OTLP logs collection out of the box. And we also support backfilling mechanism for up to 48 hours. And we plan to expand some of the capabilities as we go towards GA, but currently in public preview, these are the two main data sources that we support. All right. So let's talk about how the deployment would work. One thing to note over here is Edge pipeline is a component that is meant to receive the data. It doesn't do any scraping or collection at edge. And we'll talk about how that end-to-end will work as well. So in terms of deployment, there are some prerequisites such as you need the required resource providers to be registered. You need to have a custom location in place. Or you can create a new one. But essentially, like if you are using our Azure Portal UI to get started, we do everything for you behind the scenes. We created a for custom location and everything for you so that you don't have to worry about creating each of these independently. Anyway, so once you have this prereq in place and you initiate the deployment, first and foremost, you need to deploy the extension for the Arc extension for this. So yeah, you need to have an Arc-enabled Kubernetes cluster in your edge environments. So currently the edge pipeline can only be deployed on an Arc-enabled Kubernetes cluster as a cluster extension. So once you have the extension deployed, the Azure Monitor Pipeline Controller will create the required components like config map and the stateful set and the service so that you can open up the port. And we'll talk about all these in the subsequent slide. But essentially, once the extension is deployed, this will create all the necessary components for you to interact with the telemetry that you want to receive. And I'll now dissect the stateful set because that essentially is the pipeline instance that you will be configuring. So since it's leveraging Open Telemetry Collector as its foundation, you will have those typical components like receiver, processor, and exporter. So your receiver component is something that you will be configuring to receive the telemetry. So let's take an example. You have 100 Linux servers in your environment and you want to ingest syslogs from those 100 Linux servers to your log analytics workspace for security analytics scenario, or you want to leverage the Sentinel to kind of do security monitoring for that. So how you're going to set it up is once you install the extension on your Arc-enabled Kubernetes cluster, it will set up your stateful set and config map and the service side of the things. So this service side of the things will receive the telemetry at a particular port. So here, like I said, we offer syslog out of the box. So we have a syslog receiver in place. So you can open up a port. Let's say you want to listen to syslog at port 1234. So this particular component will decipher that and then receive the syslog. And then we have batch processor in place today, and then export it to a log analytics workspace that you have defined in your configuration. So it is that simple. Now, if you have a scenario where you want to cache and backfill, if you anticipate some connection failures, what you can do is you can set up a persistent volume of XX, GB, or TB, depending upon how much you anticipate to cache in your environment. So once you set up persistent volume, you can configure our cache engine, which will essentially, what it will do is, if it sees any failure to connect to cloud and send the data over there, it will write the data to this persistent volume, and then it will continuously keep checking for connection. And once it sees a successful connection, it will read the data from persistent volume and then send it all the way up to the cloud. So this is how the stateful set or the pipeline instance will work. One thing to note over here is any data that is older than 48 hours will be dropped. We only support caching up to 48 hours. So once you have set it up, let's see how it works. By setup, I mean you have installed the extension, you have configured your pipeline instance, and it's running. So one way you can check if it's running or not is we also send a heartbeat to the heartbeat table in your Loganalytics workspace. So just by querying that heartbeat table, you can check if your pipeline instance is up and running or not. So once you have all that things set up, let's say how the data will flow from your 100 Linux servers all the way up to the cloud. So here you have your 100 Linux servers. Now what you will do is, like I mentioned, Edge pipeline does not collect the data, it will just receive the data. So what you need to do is you need to configure your clients, in this case, those Linux servers, to emit syslogs to this pipeline instance. So one way I've seen customers doing is they typically use our syslog agent to emit the syslog at that particular cluster IP, which is the cluster where you have deployed the pipeline. And then once the pipeline receives the data at that particular port, it will forward it all the way up to a data collection endpoint. Now, this is again, data collection endpoint is something you have to set it up. But again, if you're using our Azure Portal UI, we do it for you. Essentially, this is a connection point between your Edge pipeline and Cloud pipeline so that it will establish the connection from your on-prem environment to cloud. Again, if there is an intermittent connectivity, here you have the cache setup. So like I mentioned in the previous slide, it will cache and backfill as per the configuration. All right, so once the data collection endpoint receives the signal that there's an incoming data, it'll send it all the way up to the cloud pipeline. And this cloud pipeline here, you can do some more advanced transformation stuff. So here you will receive the syslog. If you want to, let's say, filter out unnecessary data before ingesting into LA, you can do it. Or if you want to enrich the data or any kind of transform KQL that we currently support, you can do everything in the cloud pipeline and then send it all the way up to the Loganalytics workspace to store those logs. And once you have logs in place, you can use your repo for any other visualization or security analytics that you're doing. So that's how the end-to-end work. Again, just to summarize, Edge pipeline does not collect the data, it just receives the data. If you want to collect the data, you don't need to deploy Edge pipeline on each and every client. You just need to deploy Edge pipeline on a single Arc-enabled Kubernetes cluster for your entire network segment, which makes it really, really simple to kind of configure and manage. And all the resources can emit data to the Edge pipeline instance. So let's say if you, apart from the Linux server, if you have some application emitting OTLP logs, you can leverage that single Edge pipeline instance to receive OTLP logs at a different port and ingest into Loganalytics workspace. Again, since it is deployed on a Kubernetes cluster, let's say if you are receiving really, really high scale data, you can just run multiple replica sets. Now that's a property of the Kubernetes. So you can run multiple replica sets of this Edge pipeline so that it will scale horizontally and allow you to do high scale ingestion into the cloud. So these are some of the really great things about the Edge pipeline, and this is how it works in a single layer network. So now let's switch gears to see how it works across the segmented networks. So in segmented networks, it's that are typically ISA95 Purdue network model. As you can see, the two layers are separated by a firewall. So basically these two layers, they do not talk to each other. And in that lower layer networks, they do not have direct line of sight to cloud. Only the topmost layer has a direct cloud connectivity. And here I've just taken example of a 2-layer network, but essentially it's like 4 or 5 layer networks for a segmented network. So now if it's the topmost layer which has a direct line of sight to cloud, it's very simple to set everything up, like we discussed in the previous slide. But the challenge comes when when you want to collect telemetry from this particular layer, which doesn't have cloud connectivity, and send it all the way up to the cloud. So how it works is, in terms of setup for edge pipeline, everything remains exactly the same. You need to have an Arc-enabled Kubernetes cluster. You will deploy extension and configure pipeline instance. But to do all those things, you need to do it with Azure IoT Layer Network Management. So first and foremost, you need to set up this particular Azure component. It's also in public preview right now. So this particular component allows you to deploy the Azure components from cloud all the way to this particular layer, which doesn't have direct line of sight. So once you set this up, you can deploy everything that's required for the edge pipeline, like extension, configure the instance, etc. And then configure everything in terms of your clients and everything in the exact same way that we discussed earlier, and then push the telemetry directly to the cloud. So that's how it works in the segmented networks. And just to close on this, we have done a video recording with Leor on this, which has some more demos and everything. So feel free to check that out on YouTube as well. And it's in public preview. So if you have feedback or anything, do reach out to me. I would love to hear more from you. Or if you have any scenarios where you want to leverage edge pipeline and want us to support, I would love to do. So that's all from me. I don't know if we have time left for questions right now, but over to you, Kiana.
Great. It does look like there were a couple questions in the chat. One is from Carl, and then David had also asked a question. So I don't know if you wanted to address those right now, or we can take them in the Q&A section later.
Sure, I'll just respond to the chat. Yep.
Okay, perfect. And then, yeah, if you, Carl and David, if you have any follow-up questions, we can discuss in the Q&A chat. I just want to make sure that we have enough time for the remaining presenters to present. Cool. All right, Thomas, it looks like it's over to you.
Awesome. Thank you very much. Perfect. So, hey, everyone. I'm excited to talk about very cool here, at least in my opinion, today. I mean, so wait, someone took control again. So let me take this again. Okay, perfect. I hope you see all the Azure Adaptive Cloud Lab Kit slide right now. So in the last couple of weeks, I was updating a little bit on my lab environment, right? And so we talked a little bit about this within the team and said, okay, hey, look, this is actually cool. This is also something others maybe can use as well, right? I know like many of you want to try out the technologies we have. And Jumpstart is an absolute great place to do that, right? We have many, I will talk about this in just a bit, but there we have many different Jumpstart scenarios, for example, where you can try out our different technologies when it comes to Arc-enabled servers, AKS, our Azure IoT Operations Suite, and many, many other things, right? And some of them can be deployed in Azure, kind of like virtualized to like showcase them and try them out, or even if you have other cloud providers as well. But then in many cases, you probably want to really have a try and like deploy this locally in your home lab or your lab at work, right? And so that is basically what I'm doing. And so like I was looking at the different possibilities there, and I'm a huge fan of these Intel NUC devices. I will show that in just a bit, where you basically get a very small PC form factor computer, which is very silent, very small, very power efficient, and doesn't take much like basically space away from you, right? And doesn't make much noise like a real server or something like that. And still, they're very powerful enough to run many, many of these scenarios. And so I created this unofficial Azure Adaptive Cloud Lab Kit featuring the Jumpstart scenarios. We published this as a Jumpstart drop, and I'm going to quickly share my screen here that you can see how this actually works. So if you want to go into a little bit more details what this is, you can either use the link we put in the deck. We'll show that again in just a bit. Or you can just go to the Jumpstart website, which is arcjumpstart.com, and then you land on this page. And as you may know, You have many different things in the Jumpstart universe, like the scenarios I just talked about. We have the different Arc box and HCI box scenarios and Agora. But then this new cool thing also, we talked many times in this call about, there's the Jumpstart drops where you can contribute and also share other things as well, where you have very small things like different types of guides, scripts, automation, and so on. And so if you go to this, you can see here like this gallery, right, where you see all these different drops. And right now on one of the top, because it's pretty new, is this unofficial adaptive cloud lab kit drop. And if you click on it, you can see some more details here as well. So you have this fly out view where you then can go and get some guidance what it is. To make this a little bit more visible, I also have this view in GitHub button. So then you come basically to the GitHub page of the adaptive cloud lab kit. And here is a little bit of explanation going on what it is. So again, as I said, it's a small physical NUC computer, which you can buy. Like it's also very cheap, it's power efficient and so on, as I mentioned. And then you can try out different Azure technologies here using Jumpstart, right? And then like this guide goes through how to set this up that it actually works. So if you scroll down, you even have a small architecture diagram here. You can see here, basically what we're doing is we have the NUC hardware. We download Windows Server 2025 in this case, evaluation version, which you can download and then install on the NUC. There's some caveats to that, which I go through in just a bit, where the lab kit comes in. You can then enable Hyper-V and then run, for example, just some virtual machines for your infrastructure lab, or you can also run like some virtual machines with Windows Server and then install AKS Edge on top of it. You can even go so far and deploy, for example, Azure Stack HCI on top of it. And then you can basically run through the Jumpstart scenarios as well. And obviously you can connect that all through Azure Arc. So there is some caveats here, obviously I mentioned here, but just so you know, again, this is why it's called unofficial lab kit. It's not supported by Microsoft. It's not something you get from Microsoft. It's really just a guide where you take different components such as the hardware and then some evaluation software and try these things out, right? So it's not designed for production in any means, but again, to try it out as a home kit or lab kit, in that case, it's absolutely fine. You have some prerequisites. Obviously, you need to hardware for this. As well as then like some software. You need to be having a USB drive to install Windows Server 2025 on that hardware. And you, of course, you need an Azure subscription to make this whole thing work. I published some of the specs here you can leverage, which is described here, what it's going to use. And by the way, if you haven't seen one of these NUCs, this is one of the these NUCs you can buy right now, right? Very small, super quiet. And it can store up to like, I think 64, and the newer ones can even go to 96 gigabytes of memory, if I'm correct, the 14th generation of these devices. So you have plenty of memory there to try things out, right? And then the guide goes through all how you do this, how you can like install this, how you install Windows Server on top of that. And then let me quickly mute here everyone else. So the only caveat, or the big caveat here, is that these NUC devices are only designed for Windows client versions, right? So for Windows 10 or Windows 11. So there's no Ethernet driver, which comes to like where you're able to download it and make it work out of the box. So what you can do is you download the Windows 11 driver, and then you can basically force to install that driver to make the Ethernet adapter work, right? And that's what we describe here in this guide as well. So this is, again, something like an unsupported scenario, but again, great for home lab or for lab usage here. And I explain exactly how this is done. I also make sure that you know how to install Hyper-V, so you can do the virtualization part if you haven't done that before. And then is also a little bit of guide how to Arc enable that system. And then, like when you have set up this whole thing, you can now go out and basically use Jumpstart scenarios and deploy this, right, for Arc-enabled servers, for Kubernetes, and so on. So there are many cool things you can do here. And there's also some links for the documentation about this part. Now, before I finish, one thing I want to basically quickly highlight is that you can also contribute to this, right? So this is very basic. We just started this, or I just started this project. But if you want to contribute and help, like if you build some other automation, you want to fix some of the documentation or you want to add something which is pretty cool to it, feel free to do that. Do this for the lab kit. Again, you can do this on the GitHub page, or you can also do this, obviously, build other Jumpstart drops out of it, right? So if you want to contribute, you basically can go to the Jumpstart website, and then on the top side here, you can create your own drop here and basically come out here, get some guidance on how to create that drop and add something to it as well. So with that, I want to give a word back here. So Kiana, if you can share the slides again, that would be great.
Yep, awesome. Let me go ahead and bring those up. And then I believe, Arnav, you're on deck. Let me just go ahead and start sharing.
Awesome. Hey,
It is
folks.
loading.
Oh,
All right, hang on. It's going to make me start from the beginning. There we go.
no worries. Great. Thanks so much, folks. I wanted to provide a couple of quick updates on the Arc server side of the house. We had our Connecting Machine Agent 1.44 release this last month. There were quite a few extension service enhancements you probably saw, where we added a lot of validation logic with our extension reporting, increasing some of the extension sizes as well. We also had some updates for our hardware profile capabilities because of some of our upcoming Windows Server capabilities, and updated some of our error JSONs as well with more detailed troubleshooting. There was also a fix released for our SMBIOS GUID issue that some of our ESU customers faced. One thing we did want to flag is this is the last official version to support Debian 10, Ubuntu 16.04, and Azure Linux 1 or Mariner 1. And we will begin to block installation of unsupported OS and distros going forward for outdated distros, basically. And so we will continue to support these distros for the next year because that's our sort of maintenance period for previous agent version, but this is the last agent version to support some of those distros. So we did want to flag that and highlight that these were some changes that we had in terms of distro support, and obviously allowing us to drop that distro support allows us to maintain newer distros in OS, which we're always looking for customer feedback on where you'd like us to introduce support for. Additionally, wanted to flag that we've published new security guidance. You can see that there in the security overview from Arc. So everything from our identity to best practices for locking down the agent to network security. We have a really robust security guidance that we've published specific for Arc server best practices for deployment, almost 10 plus documentation articles. So we'd love to get your feedback on that and think it's going to be a really valuable resource for you if you are one of those people that reads our docs. So hopefully everyone. All right, next slide. We are excited to announce that the ESU transition scenario, which I shared in a previous call, is now generally available. So you'll be able to see this in Azure Portal. So this is for customers that had purchased year one of extended security updates through volume licensing. As you can see, you're going to have a place in Azure Portal when you provision licenses specify, hey, this is my invoice ID number for year one of ESUs. And so year two and forward, you can switch to Arc and you're not going to get back billed for that year one. So if you specify that VL ESU license ID for year one, again, your billing starts October 2024. You don't get back billed for year one, but you need to specify that invoice ID when you provision the license. So we're excited to announce that that's generally available. We have the transition scenario documented as well with our blogs in that resources section. If there's any issues, please let us know. But we know this was a long time coming, especially with year two of ESU starting. Awesome. And then in the final slide, we wanted to give a little sneak peek of something that's coming up that we know has been a really anticipated feature, which is auto agent upgrade. So as you know, we have the connected machine agent. You have to keep that updated every month, basically, with all of the different advancements that we have. We know a lot of folks really want to sign up for this. So with the auto agent upgrade capability coming up, you'll start noticing there's some like cron jobs that are running with our connected machine agent if you're paying attention with our Arc connected machine agent service. That's going to allow you to basically configure like with auto extension updates and keep that on off. Again, we want to specify that you can rig this, so you can specify the exact devices that you're going to turn Auto Agent Upgrade on for. There's some rollback capabilities as well. And we're building this into a broader sort of maintenance window story for keeping agent and extension up to date. So if you're interested in the preview for that, please sign up there and coming soon. Awesome. That's everything from my end. I know we have another speaker, so really appreciate it, and stay in touch if there's anything Arc Server related. Thanks.
Awesome. Thank you, Arnav. Perfect.
Yep. So I'm not sure if I'm another speaker again, but thank you, Arnav. That was great. Yeah, so I'm here again. I quickly do something which I got asked by our friends from the Azure Stack HCI PG. And they want to learn a little bit more about your physical network switches and infrastructure so we can optimize, obviously, our products and deployments and so on. So they have a quick survey which you can fill out if you would be so kind to that, so that we can learn how your physical setup looks like, and we can optimize this a little bit more and understand a little bit more what our customers are using. So there's an aka.ms link for you, which you can use. So you go to aka.ms/HCI network switch survey, or you just click on the link here. I think it's an interactive link you can use right now. This will take you to the form, and we'll also share it later in the chat so that you can basically go and look at this as well. And again, we're super happy to get your feedback there, what you have to, so that we can optimize Azure Stack HCI deployments. So yeah, that was it.
Awesome. Thanks, Thomas. Just realized I totally forgot to come on camera for the first half of the call during introductions. But wanted to close out, I guess, this call, obviously, with our next call that's going to be in September. So feel free to join us again the next first Wednesday of next month. And then with that being said, we can go ahead and engage in the Q&A section. So I know Carl had a couple questions, and for some reason, Teams is being crazy as usual. So the first question is, where is the cache, and this is for Zima, where is the cache data saved?
Yeah, so cache data, you need to set up a persistent volume. So once you have set up your Arc-enabled Kubernetes cluster, you can set up the persistent volume. And during the intermittent connectivity, the cache data will be saved in that persistent volume. So you can define how much size do you want to allocate to the persistent volume and all that, and it will just write to that.
Okay, and then I think his follow-up questions were, is there a total limit in gigabytes, and then can we specify the maximum gigabytes and location?
So we don't offer configurations to set up persistent volume because that is outside of the edge pipeline control or experiences, because it is something that you will be doing in your own environment. So you can do some math. Let's say you expect the connectivity to be down for, let's say, an hour for some maintenance reason, and you typically emit 5 MB logs per second. So you can do the math, like how much MBs or GBs will be accumulated during that 1 hour, and accordingly you can set up the persistent volume of that size. And I think there are some open source Kubernetes documentations as well that give some guidance on how to set it up. You can refer to that as well.
Awesome. Thanks for that. And then his last question, Carl, also feel free to come off mute if you have any additional questions regarding this, is there a view that shows a gauge how much GB data is processed per endpoint, so we can assure that we are not running out of space or losing too much data if a network outage happens?
Could you clarify the question, GBs per outage for cache specifically, or do you want the throughput that how much edge pipeline is sending to cloud? Yeah, go ahead.
Hello. Yeah, I mean, I understood that there is a local cache on the machine for things like when there is a network outage, then it's cached locally. Is this a misunderstanding?
Yeah, it's a local cache. Yeah.
And how large can this cache grow, actually?
I mean that something that will be determined on your environment. I mean, how much telemetry is your resources, are your resources emitting and all. I mean, we do not have any control on the cache side of the things. I mean, it's on customer to define the size and to set it up. All that edge pipeline will do will get the configuration to write to cache. That's it. So if you anticipate 1 TB of data to be cached, you can set it up for 1 TB. If you feel like 10 GB might be enough for the intermittent connectivity that you may be facing, you can set it up for 10 GB. It's highly dependent on how much volume you anticipate will be cached during the intermittent connectivity. Does that help, Carl?
Okay. Yeah, because I have read something recently on Tech Community where it's a fixed size of cache, like, let me say, this might not be an accurate number, but like 10 or 20 gigabytes on the OS drive.
No. So first of all, you cannot set up cache using edge pipeline, right? Edge pipeline is just a means for you to route the data, right? Yeah. So edge pipeline will simply write to the cache, but the cache definition and everything will be governed by customer.
Okay, thank you, Seema.
Yep.
Awesome. And then it looks like David also had a question. Can the edge pipeline be scheduled rather than just sending it when it sees network connectivity?
So we schedule for backfilling. Is that what you mean, right?
Yeah. So what I'm meaning is obviously we may have environments that we want control over the sending of that data. So we prioritize the link on a given time for sort of daytime traffic, and maybe you want to push the logs in out of hours, as it were.
Yeah, that's a good feedback. Actually, we have also heard that from some of the other customers that they want to schedule the backfilling so that it doesn't. Definitely on our radar. So maybe after GA of the pipeline, we do plan to expose some of these grander controls in terms of backfilling. So, David, if you could also share some of the requirements that you've been hearing, I think that would be wonderful.
No worries. Thank you.
Yeah.
All right, I know we're out of time here technically. There is one more question. I think it was from Sanjay in the Q&A section, and he was asking if there's any documentation on how to enable syslog agent on end device and persistent volume on HCI.
I'm not aware of, I mean, that's outside of our purview, so I'm not aware of if any documentation exists, unfortunately, but so there are some open source documentation on how to configure the rsyslog agent and send it to edge pipeline. So that's a good starting point to refer that. I'm not aware of persistent volume on HCI though.
All righty. I know that, again, we're out of time, but if anyone has any other questions, feel free to post them in the chat. We'll still have access to the chat even after this call ends. So if you think of anything afterwards, like I said, feel free. But I do want to be respectful of everyone's time and close off the call. So I just wanted to say thank you, everyone, for joining the call today. Feel free to connect with us through our GitHub. Be sure to join our new LinkedIn group. And if you want to see any specific topics covered next call or future calls, feel free to submit feedback through our form there. But I appreciate everyone for joining today.